Good morning, class. Welcome back to AET 830, Internet of Things and Industrial Applications. So for the first two units, we have covered the definition of Internet of Things, and we also highlight some architectural and business issues of IoT. For this unit and also the next unit, we will cover some technology fundamentals of IoT. So, but as I know, many of you are not from the background of computer science, information technology. So the technology fundamentals here will focus on the introductory level. Basically, you need to know some terminologies about what they are used for. But for the details, we don't need to go into them. But the idea is that later on, when you really move into this IoT fields, or you work on your project, when you come out with terminology, then have an idea of what it is. Or you will be able to, you remember a terminology, a technology by its name, maybe a little bit impression of its function. Then you can come back to other materials to find out what it is used. Basically, this unit and the next unit is just to open your eyes and get familiar with some terminologies, but no high-level detailed technical requirement is needed. Okay, so for this unit, we'll cover three topics. We'll talk about the devices and gateways in an IoT network. We'll also talk about the local and wide area networking. So just basically telling about some predominant popular technologies used there. And basically, many of you should have known their names. For example, Wi-Fi, Bluetooth, but just try to organize them into a knowledge system. And also, we'll talk about the role and importance of machine intelligence in IoT, because we have a lot of data in IoT, so we need to make use of them by using machine intelligence. So the content of this chapter comes from the chapter 5 of the textbook. And actually it is just half of the chapter. We'll cover the remaining half of the chapter in the next unit. So, and from this unit on, so as I realized and some of you suggest, so for the videos, we'll focus on helping you to streamline the content of the lectures. Basically, we will not go into much details, and we will not go into every single sentence of each slide, because as I mentioned, so the slides come from the textbook, so that if you don't have financial capability, then you don't need to buy the textbook. You can still learn very well. But on the other hand, that makes me have to put a lot of things in the PowerPoint, because some of them are just for you to read. From this video on, the videos will focus on helping you to organize and help you understand the streamline of the content. But some detailed information, I will leave it to you to read after the class from the PowerPoint. And also this will be able to reduce the length of the videos, because if a video is 45 minutes, something like that, 1 hour, then it's very exhausting for both you and me. But if I just using the video to guide you through, help you to get a basic understanding what it covered, and then you go into the reading for more details, then I think it's a better way to organize and to understand. And also you can save more focus during the maybe 20-25 minutes video. Okay, so I talk a lot of here. So let's go begin. First of all, we'll talk about the devices and gateway systems. So actually we use the term device a lot during our daily life. So under the context of the Internet of Things, we consider the device is an embedded computer. Okay, the keyword here is computer, and it has some properties. And for a device, it may contain some or all of the following. Okay, this is something you need to pay attention. Actually, we released a lot of features here, but for something to be called a device, it does not need to have all of them. But if it has all of them, it's even better. It's more powerful. But sometimes we don't need a device to have all the functions. So actually, these probabilities are straightforward. So for a device, because it is an embedded computer, right? So you need to have some computational capability, and you need to have power. Power depending on power comes from wired, battery, or energy harvesting and hybrid. And for devices, especially IoT device, we need to have sensor and or actuators. Sensors, you know what they are, right? Actuators means that something that can be activated to provide sound, to provide motion, to provide display, those things. And also for IoT devices, most of the time it needs to have communication interfaces. So maybe wired or wireless communication like Wi-Fi, Bluetooth, and you need to have an operation system. Sometimes it is very simple. It is a main node. Basically the program, the device will just run the code one time after another, just repeat. And sometimes it can be event-based, or if it is a full-featured operation system like Windows, like iOS, so it is more powerful. And it needs to have user interfaces like display buttons, and also it needs to have device management and execution environment if possible. So these are the features of the devices. So for the devices, some of them need to be some of the functions mentioned need to be hosted on gateway types devices instead. So a daily life example of a gateway types device is the router, the wireless router in your house. Basically, you use your laptop, use your mobile phone to connect to the router, then the router is connected to the internet. So it is a gateway, right? The gateway between your house networking to the larger network of internet. So in that case, the benefit is to reduce the energy consumption and also reduce the cost. And also we have a central node to handle the functionality such as device management and advanced applications. For the gateway type device, usually it is wired. It has power line connected to it. So we have better communication and computational capabilities on the gateway. So it's easy to understand. For example, if you unplug your laptop from the power, so you feel that it's running slower, right? So for my laptop, it can play video games very well when it is plugged in. But if I unplug the power, so it just got stuck. And also by using a gateway type device, it can help to reduce communication overload. So for the device types, actually there is no clear criterion today, but generally we can follow this, you can call it a standard or tradition, IFC 72281. Actually, there are only two types of device, roughly. Okay, we have the basic devices. It can only perform simple tasks. It can use to communicate locally, and it requires a gateway system for internet connectivity. So in that case, for your iPad, for example, right? For iPad, it can use Bluetooth, it can use Wi-Fi, but you still need to have a Wi-Fi hotspot, which is actually a gateway device to connect to the internet. And for a basic device, it has some typical features. So if you're familiar with the electronics, a good example is Arduino. On the other hand, for advanced devices, it holds application level logic, basically the apps or the functions, and also complex communication protocol stacks. They also feature the data management capabilities, and it can host multiple applications, just like your Windows, right? The Windows operating system you can install a lot of different software, and there are some features. With that in mind, so Raspberry Pi is an example of advanced device. So for this table, it summarizes some basic, some comparison of the basic and advanced device. So, but as we know, sometimes the boundary between these two types are not very on and off. It is not this or that. So sometimes there are some overlap. For example, for the iPad, okay? For the iPad, although most of the time it can only communicate locally, and it needs to have a Wi-Fi hotspot to connect to the internet, right? Which seems to belong to the basic device, but it can definitely have very complicated apps there, right? And it can also have Wi-Fi and Bluetooth, and also it can data management, and it has definitely have multiple applications like apps. So in that case, iPads may be more close to advanced device, but the only limitation is that it cannot connect to the internet without a gateway Wi-Fi hotspot. I know some upgraded iPad can have the SIM card, SIM-S card there, just like using the cellular data. In that case, it is definitely an advanced device. Okay, so here are some scenarios for different types of devices. So for basic devices, we have the home alarms. So we have the smart meters. So I will leave this reading to you. We have the building automation system, and also have the stand-alone smart thermostats. And for the advanced devices, so we have the onboard unit cars, we have remote monitoring configured over a cellular connection. So as we mentioned, for cellular, if it uses cellular connection, basically the cellular data, so it does not need a gateway, right? So it is more close to advanced device. And also we have robots, video cameras for remote monitoring, and oil well monitoring, and connected printers. Those are some examples of advanced devices scenarios. So for the devices and gateway of the day, they often use legacy technologies, such as this kind of, So for this class, just remember the ZigBee. So many local communication are actually implemented based on ZigBee. But the future, that's something to remember. Future, we hope that every device will have an IP address that can be directly or indirectly connected to the internet. So that's the future. Okay, now let's go into the basic devices a little bit more detail. So basic devices, so the intent is for simple purpose. So the main focus is to keep the bill of materials as low. Basically, it should be not that expensive. Just imagine that you need to deploy thousands of sensing devices over the forest, for example, to detect forest fire. So if every device is if there are thousands of dollars, so the cost will be too high, right? In this case, introduce a term SoC. SoC means system on a chip. Basically, it indicates a small computer, SoC. So this is an example of a microprocessor typically used in the basic device. So earlier SoCs, system on a chip, use one microprocessor. So modern models, they will use two or more microprocessors. So basically, one may be handling the calculation, one is handling the communication. And for the microprocessor or microcontroller, it have a lot of ports, or sometimes we call it pins. So basically, those are if for your impression of a chip, usually you see it has many legs, right? Basically, those legs are related to the ports or pins, have the general purpose input, output, and also some communication pins. And also we have some sleep modes or interrupt to save the energy. So sleep mode means that it is not working for a while, it will just sleep to save the energy. Because for basic device, we mentioned that most of the time it is using battery, right? So which want to save energy. And for the basic devices, if possible, we would like to harvest the energy from their environment. For example, from the temperature, from their motion. So some sensors, some people are investing that. So for some devices you are wearing on your body, so when you move, they try to harvest the energy from your motion. So that's one way. Okay, for the basic devices, most of the time they use serial interfaces to communicate. Yeah. Serial interfaces benefit is that it only requires 2 wires. Okay, so as we mentioned, so basic devices lack WAN interfaces, WAN wide area network. Basically, that's what you need to be connected to the internet. We'll talk about it in the next video. So in that case, we need a gateway to do it. So the gateway together with connected device forms a capillary network. So just imagine your house. So you have a router, wireless router, which is a gateway, and your laptop and your mobile phone and your iPad are connected to the router. So basically, it is a good example of capillary network. So the microprocessor will run software on it, and also antennas and associated circuitry are needed for wireless communication. So following this standard. So that's one of the standards you need to know what it is after this class. Basically, it is the wireless personal area network. Yeah, we'll talk about it in more detail in the next video. And also for the operation system, basically they try to use a lightweight operation system. For the application logic, basically the program. So it usually have a main application. Basically, if you have a little idea of programming, basically it has a main function, and basically the device will just run the main function time after another in a main loop. So in that case, it's not that smart, and it cannot run very complex programs. Just now we mentioned that most of the time we need gateways to connect the basic devices to form a capillary network. So a gateway typically includes multiple networking technologies and serves as a translator between different physical interfaces and protocols. So for example, the IEEE 802.11 here. So then you may not know what it is, right? But if I tell its common name, you will definitely know it. So basically it is Wi-Fi. So for the Wi-Fi, for the Bluetooth, basically they have the standard. So for example, the IEEE 802.11 here is the standard for Wi-Fi. So for your router, once again, within the capillary network in your house, you use Wi-Fi, right? To connect to your laptop to the router. And then the router, we use the Ethernet, basically the wired cable, to connect to the internet. So the router is a translator. So basically it works like this. So this is the gateway, and you have many basic devices or other devices connected to it to form a capillary network. And then the router will connect you to the internet. Basically, internet, you can think it is a very big network, wide area network. So people from different countries can work together, for example. So a more detailed explanation is here. So you can read it to get a better understanding. But if you don't read it, it is also fine for this one. For the gateways, so for basic gateways, the hardware is focused on the communication or the translator role, but sometimes we can add some additional tasks. So additional tasks, first one is data management. So for data management here is implemented in the gateway, okay? And also we can also run local applications and data management functions, because the gateway, as we mentioned, it is usually wired, and usually it has better computational capabilities. So we can run some applications in the gateway. So nowadays, some wireless routers also can run some applications. For example, they can try to manage, you can manage the devices connected to your router. Basically, it has an internal application which you can run. Also, the benefit of hosting the logic in the gateway instead of in the network is to avoid downtime in case of the internet connection failure and minimize use costs, cellular data, something like that. So basically, the router or the gateway can serve as a computational unit. So that's what brings the idea of edge computing. So you may have heard of cloud computing, right? So edge computing, on the other hand, is trying to use the gateways because we have a large amount of gateways. Basically, every wireless router and other gateway devices can do some computation work. So people are thinking about, why don't we use this computational capabilities to do something? That's the base for edge computing. And also for the gateway device, it can also run the lifecycle management of the running applications. Okay, now let's come to the advanced devices. So advanced devices, usually it has the following characteristic: a powerful CPU. So basically, you just think about your iPad, okay, or your cell phone with enough memory. So yeah, to run advanced applications, just think of the video games on the iPad. So it's very advanced, right? And it has user interface, of course, and high bandwidth functions. Basically, it needs to have good communication capabilities. So, for example, you can definitely watch videos, HD videos on your iPad, right? And also, it have unlimited supply of energy. So it depends. Well, of course, you can always plug your iPad to the power, right? But after it is a portable device, you can definitely unplug it to use for maybe 8 hours, depending on what apps you are running. So definitely iPad is an advanced device. Because the advanced devices have such good powerful capabilities, it can also function as a gateway. So it can provide the operation system. It can also perform high performance IP stacks. IP, so you know that's the IP address, right? So above are the introduction of the basic devices, advanced devices, and also the gateway. So basically, most of the time, the advanced device can be used as the gateway because it provides the needed capabilities. So to summarize, so for the devices, we need to think about their security, and we need to think about the external environmental factors. So I have an example of my own invention. So a few years ago, I was traveling to another state during the winter break, okay? But I have some fish in my house. So I used the Arduino to develop a fish feeder. Basically, I put it on top of the aquarium and do some programming and also put some activators on it so that it can pour the fish food into the aquarium tank every day, okay? So I believe my program was correct, but it turned out but the system was not working. The reason is that the above, there was too much humidity on top of the aquarium tank. Basically, the system just failed, right? So basically, external environmental factors need to be considered when deploying such devices. And for the IoT, the devices will disrupt the current value streams by introducing new types of actors. That is basically quite similar to the stakeholders in the system. And also, another potential outcome of improved interoperability is possibility to reuse the same device for multiple services. So for example, a motion detector can be used for security purposes as well for reducing energy consumption in the absence of activities in a room. So this is the vision. So also, technology been always advancing. So entirely new devices, classes, and features are expected, such as battery-powered devices that use such kind of cellular connection and other stuff. You can read about this. Okay, so that's for the first topic in this unit. So the devices. So in the next video, we talk about the LANs and the WANs.